This Introduction to Python series is part of the EPSCoR Track 2 DDMD workshop. This presentation deals with error handling within your Python code. Up to now, we haven't talked a lot about error handling. But it's really important that your program anticipates errors and that you handle them gracefully. There are at least two distinguishable kinds of errors. There's syntax errors and exceptions. Syntax errors are generated when the Python coding rules are not followed. So let's consider this example. I is assigned 0. While I is less than 10, print I. Here we have a syntax error, and when you try to run this program, an error message is generated. And the error messages are really quite informative. It tells you that the error is on line 2. It tells you it's part of the while statement, and it actually even points. You see that caret that points to where the syntax error occurred. There's a syntax error in this code because we neglected to put the colon after the 10. Even if a statement or an expression is syntactically correct, it may cause an error when an attempt is made to execute it. Error detected during execution are called exceptions. If the exceptions are not handled by the program, it results in an error message being generated. When an error occurs, or an exception as we call it, Python will normally stop and generate this error message and display it on the screen. Let's consider this example where we calculate the average grades. So we're asking the user to enter a set of grades, and specifying a -1 is the sentinel to signal that they're at the end of entering grades. So there's a variety of places where an error can occur. First, let's look at what happens if the very first grade that's entered is a -1. So we set sum equal to 0, number of grades is assigned 0. Then we ask the user to enter a grade. Well, the user enters a -1. The while loop is never executed, and the control, because grade is not greater than or equal to 0, so control of the program goes to the statement under the while loop, and we calculate average. So average is assigned sum divided by number of grades. The problem is the value stored in the variable number of grades is 0, so this would generate a division by 0 error. So when a division by 0 exception is generated, the Python interpreter displays an error message on the screen. And this error message provides some valuable information. First of all, it tells us the type of exception that was thrown. And in this example, the exception is a 0 division error exception. It tells us that this exception was thrown on line 9, and it tells us specifically that it's division by 0. The last line of the error message indicates what happened. Exceptions come in different types, and the type is printed as part of the message. Some of the type examples include 0 division error, name error, value error, and type error. The string printed as the exception type is the name of the built-in exception that occurred. The rest of the lines provide detail based on the type of exception that was caused. One of the ways we can modify our code to ensure that a division by 0 exception isn't thrown by simply adding an if statement. So before we calculate the average, we can check to see if number of grades is greater than 0. So we can, in our if statement, add the condition, if number of grades is greater than 0, go ahead and calculate the average. Otherwise, inform the user that no grades were entered. So here's an example of running the program where the user enters a -1 as the first grade entered. In this example, the while loop isn't executed and number of grades is equal to 0. So we execute the if statement. If number of grades is greater than 0 and it's not, the print statement within the else is executed and no grades were entered is displayed on the screen. Python provides a try except clause that allows us to catch exceptions that are thrown and to be able to handle them gracefully. The try and except block in Python is used to catch and handle exceptions. Python executes code following the try statement as a normal part of the program. The code that follows the except statement is the program's response to any exception in the preceding try clause. This is an image of the general try except construct. The block of code under the try is run as part of the regular program execution. The block of code under the except is executed when an exception is thrown. When an error occurs, or an exception as we call it, Python will normally stop the execution of the program and generate an error message that's displayed to the user. These exceptions can be handled more gracefully by using a try statement. The try block lets you test a block of code for errors. The except block lets you handle the error. The finally block lets you execute code regardless of the results of the try and except blocks. So let's consider how we might use a try except in order to handle a division by 0 error. So in the try block, we would execute the statement to calculate the average. So we would have sum divide by the number of grades and assign that to average. If number of grades is equal to 0, it would throw a 0 division error exception, and the print statement in the except block would be executed, and the user would be informed that no grades were entered. So in this example, the try clause, the statements between the try and except keywords is executed. If no exceptions occur, the except clause is skipped and the execution of the try statement is finished. So in other words, if number of grades is not equal to 0, the code under the except would be skipped. If an exception occurs during the execution of a try clause, the rest of the clause is skipped. Then, if its type matches the exception name after the except keyword, the except clause is executed, and then execution continues after the try statement. If an exception occurs which does not match the exception name in the except clause, it is referred to as an unhandled exception, and the execution of the program stops with an error message displayed to the user. Here's an example of a try clause where in the except statement, we're catching a value error exception. But when the code is executed, when number of grades is equal to 0, a 0 division error is thrown. Therefore, the 0 division error is not caught, and that's an unhandled exception, and an error message is displayed on the screen. One option we have is omitting the error type for the except clause. So notice here that we have the except keywords, and we have eliminated any specific error types. In this case, any exception that's thrown, whether it's a 0 division error or a value error or a name error, they'll all be caught. And if any of those are thrown, the print statement within the except will be executed. The advantage of this is it'll catch any exceptions. The disadvantage of that is we're not able to give specific error messages to the user to let them know exactly what happened. Let's go back to our calculate grade average program. We've already talked about how we would handle division by 0 if the user enters a -1 as the very first grade. Now let's consider what happens if the user enters a letter grade instead of a numeric grade. So if you look at the statement, grade is assigned float, parentheses, input, enter grade, enter -1 to quit. What would happen at this point if the user entered the letter grade A? Let's examine the Python statement that asks the user to enter a grade. So the specific statement is grade is assigned int, parentheses, input, parentheses, and then the prompt, enter grade, enter -1 to quit. So the way the interpreter executes this line of code, the first thing that happens is enter grade, enter -1 to quit is displayed on the screen. Then execution of the program pauses until the user types in something at the keyboard. In our example, the user types in an uppercase A. The interpreter accepts this A as input, and it becomes a parameter into the int function. So the int function is trying to convert the uppercase character A to an integer. Well, this is not a valid string for the int function. The int function is expecting a string that actually represents an integer. So the interpreter throws a value error. So you can see the type of error message that's displayed on the screen. So you can see that the type of error that was thrown was a value error. You can see that that exception was thrown on line 3, and you can see the description of the error, invalid literal for the int function with base 10. So this description is telling you that A is not a valid literal for the int function. Here is one example of how we might be able to gracefully handle the error message if the user types in an incorrect value for the grade. So we can create a while loop, and basically we say while true, and we know that a while loop will continue running as long as it's true. So this is basically an infinite loop to begin with. So we say while true, then we're going to have the user try to enter a grade. And let's say that the user enters an A. An exception is thrown, and we tell the user that's an invalid grade. Please enter a grade between 0 and 100. Execution of the program goes back up to the while loop. And because while true is true, it's going to execute that loop again. So we ask the user again to enter a valid grade, and this time the user enters a grade, maybe a 56. That is a valid grade. That 56 is entered. It's the input is a string. That string is converted to an integer, and the integer value 56 is assigned a grade. Then the break statement is a statement that allows you to just break right out of the while loop. So this will break you right out of the while loop, and the statement following this while loop will next be executed. Here's an example of modifications that I made to our calculate grade average program to ensure that an unhandled exception isn't thrown. So the initial read of a grade, I included that while loop so that we make sure that the first grade that's entered is a valid grade. And then we have to continue adding grades. So within our while loop, as long as grade is greater than 0, we want to make sure that the user enters a valid grade. Here's our completed example for calculating grade average, where we've included error handling for grades being inputted by the user, and error handling to verify that we don't have a division by 0 error.